14 through 24 even. 14, your answer should be 3 to the 5th power.
Yes.
16, when you write 16, you need to make sure that you have it in parentheses. So you have a negative 14 cubed. You have to have the parentheses because it's completely different when you don't have the parentheses there. 18, again, it needs the parentheses. So it's a parentheses, a negative 1.5 cubed. 20, you should have 5p cubed cubed. So 5p cubed cubed. That's a lot to say. 22, 8 times the quantity, c plus 4 squared. 24, the quantity, 2x plus 3y squared. Then we went to number 34. 34, your answer is 7.
No, I think.
Okay. Are you just testing me?
No, I'm not.
Oh, okay, just checking. All right, 34 is x squared. So x is a negative 2. So I have to have a negative 2 squared plus 2 times y is 3 minus 3. Did I set it up correctly?
I realized
Okay.
my mistake.
So a negative 2 squared would be a positive 4 plus 6 minus 3. 4 plus 6 is 10, minus 3 would be 7.
I realized my mistake.
That's all you have to do is find your mistake.
I forgot to put the 3 in. The
36, you should have 1,024.
Yep.
Okay, I have someone with their hand up. So you would have 4 times y plus 1. Y is 3 plus 1. And that's to the 4th. So really I have 4 times 4 to the 4th. 4 to the 4th is 4 times 4 times 4 times 4, correct? And really I can just bring down this other 4 if I, right? 4 times 4 is 16. 4 times 4 is 16. So then I would do 16 times 16, get my answer, and take that times 4 again. Does that make sense? I'm sorry?
I still don't know
You don't know where you went wrong? Okay, well, I guess I better do my multiplication then. 6 times 6 is 36. 6, 7, 8, 9. 0. Cross that off. 6, 1. So I have 256. Right? Am I doing this correct?
Yes.
4 times 4 is 16. 16 times 16 is 256. Am I correct?
Yes.
Okay, then 256 times 4. 4 times 6 is 24. 20 plus 2 is 22. 8, 9, 10. 1,024. And the last 138, you should have gotten a negative 10.
Yep.
Okay, so I have somebody that has their hand up, so let's just pay attention here and make sure. X cubed, x is a negative 2 cubed plus 6. So that's like saying a negative 2 times a negative 2 times a negative 2. Do you understand that that is this? So a negative 2 times a negative 2 is a positive 4. A positive 4 times a negative 2 is a negative 8. A negative 8, then bring down the plus 6 would be a negative 2. And then a negative 2 times a positive 5 is a negative 10. All right, go ahead and turn in your books, and we're going to get started right away into the next lesson, which is talking about negative exponents. So go ahead and look at Page 141. When I first look at negative exponents, I'm like, how in the world do we do this? And then I'm just like, you know what? Like sometimes it's like, why try to figure it out and just come up with something easy and follow like that rule? And then it made it a lot easier for me to figure out. I am going to explain it all to you because sometimes the explanation might help some of you. Sometimes some of you just need to know it. Just this is how you do it. That's what you follow. Okay, it just depends what works for you. So it says we have negative and zero exponents. When there's a zero exponent, we already talked about this. What is it always equal to? 1. And here it is. X to the 0 power is always equal to 1. But x can never equal 0. This always has to be some kind of number that's not 0. Okay? So I can have 256 to the 0 power. It's going to be 1. Here's where they're going to show the negative exponent. All you do is you make it a fraction. That's it. You take whatever the exponent is and you put it underneath 1. Does that make, so I'm going to go give you some examples here. So I have 8 to the negative second power would be 1 over 8 squared. So basically, making it as a fraction, you're getting rid of that negative sign. In explanations here, it says a negative exponent is a result of repeated division. Because an exponent, a normal exponent, a positive exponent is repeated multiplication, right? So this is repeated division. That's why I just know I make it a fraction. And it's always underneath the number 1, okay? So extending the pattern below shows that 1/100th or 1 over 10 squared can be defined as 10 to the negative second power. All I think, that's negative, so it goes 1 over 10 squared. 10 squared is 100. You need to, whatever that bottom number is, you need to either square it or give it the cube root, because you can have something to the power of a negative 5. It doesn't matter. You're just always putting it over 1. So here they're showing the exponential form. So 10 cubed is 1,000, 10 squared is 100, 10 to the first power is 1, 10 to the 0 power, 10 to the first power is 10, 10 to the 0 power is 1, 10 to the negative 1 is 1 over 10, 10 to the negative second power, because you're not going to say negative squared usually, you'll just say like negative second power, would be 1 over 100, and 10 to the negative third power is 1 over 1,000. Do you guys understand how we're going through this? Okay. To me, I'm like, all this division stuff, because you're going to get different powers than 10, this number is going to be different. All I just remember is put it under 1. Make it a fraction. So we have some examples here. It says write each expression using a positive exponent. So this is the number 2. Okay, so see, it's not always in the power of 10. So it's just going to be 1 over 2 cubed. Do I need to solve the 2 cubed for this one? No, because it says use a positive exponent. That's all I have to do. Does that make sense? So for m to the negative 4th, it's just 1 over m to the 4th power. You're just making it a fraction. Go ahead and do 1a, 1b, and 1c all on your paper. I want to see all of these. And you can leave it as an exponent. I'm going to have to start marking you unprepared. You should have 3 different answers. So 3 to the negative 5th should just be what? 1 over 3 to the 5th. Sometimes they're going to ask for you to figure out what 3 to the 5th is also, but this time they're not. Y to the negative 3rd would be 1 over y to the 3rd. 2 to the 0 power is 1. That's it. I'm done. Now this section asks us to write a fraction as an expression using a negative exponent other than negative 1. Okay, so we're just going to go the opposite way. If it's 1 over 4 squared, that would just be 4 to the negative 2. Okay? This is 1 over 100, so that'll be 1 over 10 squared, which would be 10 to the negative 2nd. You want to figure out what that is first with an exponent. So 1 over 6 cubed would just be 6 to the negative what? 3rd, right? The negative 3rd. What is this? So basically I have to find this with a square or a cube root of some sort. What can I do to get to 25? 5 squared. So this would be 1 over 5 squared, right? Then you show that it would be 5 to the negative 2. I want you guys to try to figure out 2C. What can I do in order to get to that? If you don't know where to start to get 27, do the prime factorization. 3 times what is 27? 9. Then I'm going to factor out the 9 again to 3 times 3. So now my prime factorization of 27 is 3 times 3 times 3. So this is 1 over 3 cubed, which then you rewrite as 3 to the negative 3rd. Raise up your boards if you got it correct. Okay, do you guys understand if you don't know where to start, you do the prime factorization? Is anybody confused on that? Okay, so let's move on. Moving on down, it says negative exponents are often used in science when dealing with very small numbers. Usually the number is a power of 10. So we have example 3. Geckos have tiny hairs on the bottom of their feet that are about, this is tenths, hundreds, thousands, 10,000, 100,000, millions. So it'd be 1 millionth meter long. Write the decimal as a fraction as a power of 10. You just look, did you guys hear me talk out loud? I'm like tenths, thousands. What would be next? 10,000? Okay, because it goes tenths, hundreds, thousands, 10,000s, hundreds, thousands, millions. Then I write it 1 over a million, and then you count. How many zeros do you have? 6, so that's why it's the power of 6. That's when it's in, but your base has to be a 10. That only works when your base is a 10. So it would be 1 over 10 to the 6, which would be 10 to the negative 6. Is anybody confused on that? So it says therefore 1 million is 1/millionth as a fraction and 10 to the negative 6 as a power of 10. So let's look at some examples. The slowest moving fish is a seahorse. It swims at a maximum speed of 1. What place value is this? Tenths, hundredths, thousandths, 10,000. So I always read each place value so I know that it would be 1 over 10,000. Then I know that would be 1 over 10 to the what power? Fourth, because there are 1, 2, 3, 4 zeros. So then 1 over 10 to the fourth would be 10 to the negative fourth. That's how I would write 3a. Do you guys understand that? So let's have you guys try 3b. The smallest species of an ant has a mass of, I'm not even going to read that out loud because you need to be able to read that. Write the decimal as a fraction and as a power of 10. So I would say that is 1 over, well, this is tenths, hundredths, thousandths, 10,000ths, 100,000. So it'd be 1 over 100,000. So then it'd be 1 over 10 to the fifth, and then I write it as 10 to the negative fifth. Raise your boards if you got it. Do you understand why you missed it? You've got to be able to read those numbers. Our last and final examples are just kind of like what we had before, where it's an algebraic expression, which just means they're giving you a letter, because that makes it algebra, and they're going to give you an amount, what it's worth, and you're just going to put it in and solve it. So it says algebraic expressions containing negative exponents can be written using positive exponents and then evaluated. This is the big thing. We have to evaluate it. Evaluate just means basically solve it. So if I have evaluate 4 times a to the negative fifth if a is a negative 2. So you just have 4 times, and then make sure that negative 2 is in parentheses, times the negative fifth. You're still going to leave the 4. Because it's a negative exponent, it's going to be 1 over negative 2 to the fifth. You have to do the negative 2, and they don't show it here. They don't show it in the example, but I need to see that you're doing negative 2 times the negative 2 times the negative 2 times the negative 2, 1, 2, 3, 4, 5 of them. Does that make sense? And then a negative 2 times the negative 2 is a positive 4. Negative 2 times the negative 2 is a positive 4. 4 times 4 is 16. Then I take 16 times the negative 2, which would be a negative 32. That's how they got a negative 32. Does that make sense? Then I do the negative 1 over negative 32 times 4, which 4 is over 1, and they're reducing first by 4. And then 1 times 1 is 1. 1 times the negative 8 is a negative 8. So you have to show all of those steps. I want you guys to try to do 4a on your boards. M to the negative 2, or negative squared. So M is what? Positive 4, right? So I would write 4 to the negative squared. So then it would be 1 over 4 squared. And then it's 1 over what? 16. You had to finish and find the final answer. You can't just leave it with an exponent. Go ahead and do 4B. Everybody else. Okay, let's stop for just a second. I have 6 times M, which is 4, times N, which is 3 to the negative 4. 6 times 4 is 24, right? 3 to the negative 4th would be 1 over 3 to the 4th. You guys with me on that? Then the 24 needs to go over 1. Okay? But I'm going to do 3 to the 4th. So that's 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So now I'm going to rewrite it as 24 over 1 times 1 over 81. You guys with me on that? What can I reduce these by? So if I reduce it by 3, 24, 3 goes into 24 how many times? 8. 3 goes into 81 how many times? 27. So then 8 times 1 is 8. 1 times 27 is 27. So your final answer should have been 8 27s. Because this right here became this fraction right there. And I think that's where a lot of you made your mistake. Go ahead and try 4C. Looks like we're doing a little bit better on this one. I have a negative 3 to the negative third. So that would be 1 over negative 3 cubed. So then the negative 3 cubed is like saying negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is 9, and then 9 times negative 3 is negative 27, and it's over 1. How many, raise your boards if you got it right. Okay, let's try the last one, 4D. Go ahead and try 4D. So you have a negative 4, and then we have m, which is 4 to the negative squared. So it's like saying a negative 4 over 1 times 1 over 4 squared. You guys with me on that? So then I have a negative 4 over 1 times 1 over 16. Reduced by 4. So 1 times 1 is 1, 1 times 4 is 4, but don't forget, this is negative, and a negative times a positive is going to stay negative. Some of you could have already thought, too, that if I have 4 squared, that's 2 4s, right? And I can reduce a 4 and a 4. That becomes a 1, and this becomes just 1 4, because I got rid of the squared. So you could have reduced before you came to here, to this spot. Raise your boards if you got a negative 1 4. Okay. I think some of it is when it gets to the 4 times this is by itself. So you need to think that you have a negative 4 times this, and that became my fraction because it's timesing it by a negative. Your work is you need to get to page 143, and you're going to be doing 15 through 21 odd, and then number 33, 36, and 41. You need to write it down, what the numbers that you're going to do,